Okay, so hello everyone and welcome to the OneClass channel. My name is Donna Riel and I'm a recent master's graduate in the Materials Science program from the University of Ontario Institute of Technology. So I also took my Bachelor's of Science at this institution as well in pharmaceutical chemistry. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you had any problems with homework or tutoring, then check out the links in the description below. So now I'm just going to get started on our set of questions for today's session. Okay, so question number 1 starts off pretty broad, but basically they are asking, what are functional groups? Functional groups. So this is one of the first things you learn about when we're talking about chemistry or organic chemistry in general. And basically they are like substituents that can make your molecules unique. And they also affect how they will react in a chemical reaction. So there's a lot of different functional groups. I'm just going to get started and write down all of the main ones, and yeah, I'll just write them all down. So the most basic one in organic chemistry is just called an alkane bond. And this just represents a single bond between two carbon atoms. You can have an alkene bond, which shows that there is a double bond between carbon atoms. And lastly, there is an alkyne, which, as you can guess, represents a triple bond between two carbon atoms. You can have alkyl halides. So this is when your carbon is connected to like a bromine or like a chlorine, any of the different halogens. And I will from now on denote R as kind of like the rest of the chain. So it's just a way for chemists to, if they don't want to write out the whole like carbon group, you can just denote it as R. After alkyl halides, you could have alcohols. So again, I'm just going to do R just to signify to another carbon group. And alcohols are when you have an OH. Similarly, you can have a thiol, where instead of oxygen, it's sulfur. You can have an ether group. I'm going to write it like that. In a way, me and my friends remembered ether groups is that there's like a carbon on either side of the oxygen. So that's just how we try to memorize these different times groups. That's what an ether is. For amine, this is when you have a nitrogen involved. So the simplest amine is just like an NH2 group, or NH3. Alright, NH3. And you can have a ketone. I'm going to draw it like this. And this is when you have a double bonded oxygen in the middle of two carbons or carbon groups. So another way that we remembered this is that you put the key in the middle of two like R groups, so ketone. And what's similar to ketones are aldehydes. So again, there is a double bonded oxygen, but the only difference is that it's at the end of a carbon group. So instead of being bonded with two carbons, it's bonded with a carbon group and a hydrogen. You can have carboxylic acids. So basically, this is like putting together an aldehyde and an alcohol, like put together. And you get this group right here, where it's like a double bonded oxygen and then an OH. And then what's similar to carboxylic acids are carboxylic esters. So as you can guess, this is similar to carboxylic acid, except instead of it being at the end, it's in the middle of two carbon groups. And you can have a nitrile. So this is when we have like a carbon that's triple bonded to a nitrogen. And then lastly, you can have like a carboxylic amide. And as you can guess, it's kind of similar like a carboxylic acid, where you have a double bonded O, but instead of the alcohol group, it's gonna be an amide at the end. So these are all the different main functional groups that you can have in an organic molecule. Let's see our answer from the junior tutor. Functional groups are specific substituents that distinguish the chemical reaction of one molecule from the other. In organic chemistry, the molecules with the same functional groups will undergo a similar chemical reaction. Examples of functional groups include carboxyl, aldehyde, ketone, etc. The figure below shows the common functional groups and their structures. Okay, so you can just see a more detailed version of what I tried to show. They have examples of alkanes, alkenes, and how you can have like a double bond at the end there, not just in the middle. Alkynes can be in the middle or at the end. Alkyl halides, they showed both bromine and chlorine as an example. Alcohols, thiols, esters, which is kind of cool. They show how you can have like a benzyl ring as an ether. Your amines, so this can be like a secondary amine or a tertiary amine. So here they showed a primary and a secondary amine. The ketone, so as long as it's in the middle of two different carbon groups, that's your ketone. For aldehyde, you have the double bonded oxygen, but instead of having another carbon group here, it's at the end, so we show a hydrogen. Carboxylic acid, carboxylic ester, carboxylic amide, and then a nitrile. So this solution is correct.